All right, so one thing we need to be able to do is we need to take a look at a molecule and identify where the chiral centers or where the stereo centers are. Right, same thing, just different word for it, right? And so when we identify these things, here's what we want to keep a lookout for. It's always going to be an sp3 carbon, so you can ignore the double bonds and the triple bonds, and we'll only talk about carbon, so you can ignore any other hetero atom as well. And so not only does it have to be an sp3 carbon, it has to be an sp3 carbon with 4 different things attached, or 4 different substituents. So for example, something like this. If we think about it, there's an atom missing, right? There's also a hydrogen here. So we have kind of this methyl group, this chlorine, this alcohol, and then this hydrogen. So we have 4 different things. It's sp3. So that carbon right there is indeed a chiral carbon. Or that right there is a stereo center. And so when we say different things attached, we don't mean just directly. It can be further downstream. So differences can be more than 1 carbon away or more than 1 bond away. So for example, something like this. If we take a look at this carbon right here, we can see over here we've got a methyl group, over here we've got an ethyl group, and then over here we've got an isopropyl group. And then obviously there's one missing, there's also a hydrogen there. And so this does indeed have 4 different things to it. So this is a stereo center, which means there's a left and a right-handed version of these molecules. Let's take a look at another example. So if we take a look at this carbon right here, obviously there's going to be an H attached, right? So there's 1 different thing. The alcohol is 2 different things. But then if you look at the left and the right side, they're the same, right? And so this compound is not chiral or not a stereo center. What we call this is achiral, right? Which means not chiral. Like asymmetric means no symmetry. We put that A in front to mean that it's not there. But a simple change of the molecule can make it chiral. So for example, if we had a double bond here, right, let's take a look at it now. We still have this hydrogen here. We have this alcohol up here. And then we have this kind of alkane section over here. And then an alkene section over here. So now they are different. And so this molecule or this carbon right here is indeed chiral. So again, really just take a look at the molecule. What you want to identify is a carbon, an sp3 carbon with 4